Hi everyone. I'm going to go through the Lab 6 demo right now, and this is the lab, our final lab of the semester, linear regression. So the tools that we're going to add to our biostats toolbox, not only linear regression, but understanding linear regression so well that we also are able to understand this silly little joke right here. So the data that we're going to use for our linear regression demo is the album sales SAV. So make sure and download that on Moodle before moving on in this demo. But basically, what linear regression is it's a statistical method that allows us to summarize or model and study the relationship between a continuous dependent variable and one or more explanatory variables or independent variables. Now, the biggest difference here between logistic regression and linear regression is how our dependent variable is categorized. If it is a continuous variable, and has no categories, but is just a continuous number, then we need a different tool in our toolbox than logistic regression. Logistic regression is only designed for a dependent variable that has two different levels. So what if we want to model something that's continuous? We need a new tool. So here we have an example of a research question. This is sort of similar to a research question that we've been sort of thinking about as we thought about regression and needing to account for confounders. So here's our example question. Is there a statistically significant association between smoking during pregnancy and income while accounting for differences in education, marital status, and maternal age? So if we want to look at smoking during pregnancy and is that going to affect a woman's potential income level, and we've categorized income as continuous, our dependent variable is going to be continuous. Therefore, we're going to need to use linear regression. So once we have our research question of interest, of course, the next step that we need to jump to is to create a corresponding linear regression skeleton table. So here we have one set up. This should look very similar to logistic regression, where we have our constant for what our outcome is, and then we have all of our different confounders, our primary exposure of interest or our primary independent variable of interest, and then several other independent variables that we want to account for in our overall model. As you can see here, we're going to have our test statistic, which is also known as our beta. We have a standard error here, and then of course our p-value. And because we want to understand how much of the pie we are explaining with these variables, how much of the variation can we explain in income while accounting for just these variables, we want to also have our model fit. So this is a way to set up a skeleton table based on our example research question of interest. So now we want to jump into our album sales. So go ahead and download the albumsales.sav file from Moodle. I have it open here so we can take a look at it together. So here we have a very simplified version of a data set. This is much simpler than our Burfus data sets. So this is a really good place to start so that we can understand how to run our linear regression here in the simplified version before applying it in the more difficult, complex version of Burfus. So here we only have 4 different variables. We have our advertising budget, and the label here tells us that this is in thousands of pounds. Please remember that Andy Field is British, and so instead of dollars, we're going to be dealing with pounds. So c'est la vie. We also have 3 different independent variables down here. We have album sales, number of plays on the radio, and then also attractiveness of the brand. Oh, sorry, actually, this is not an independent variable. This is actually going to be our dependent variable. So the budget is our primary independent variable or our exposure. So if we go back here to our demo, we can see here a couple of different research questions that we could develop based on the fact that we're looking at just these 4 variables here. So how can we predict album sales? So again, album sales is going to be our dependent variable based on advertising. And again, advertising is going to be our primary independent variable of interest. But we don't just want to know that. We also want to understand whether number of plays on the radio and or attractiveness of the band help us predict album sales too. Those are going to become our two confounders. So our step one here, before we even launch into SPSS, is to build our skeleton table. So again, what we have here looks very similar to the skeleton table that we built with our pretend research question about maternal smoking and income. Is here we have a constant for album sales. So that's again our dependent variable. And then these three variables here, advertising, airplay time, and then attractiveness of the band, are the independent variables, this being advertising being our primary independent variable of interest. Okay, so as we move on here, we are going to be testing assumptions. If you noticed, I gave you a break on testing the assumptions in logistic regression for the last lab. And that's because we were really learning how to use regression as a tool in general. But now that we're pros at it, now that we've mastered how to do logistic regression and we're moving on to linear regression, there really isn't much difference. And so I wanted to add this one other thing onto this lab. I want you to be able to understand and test the assumptions associated with linear regression. So I've listed them all here. And there are definitions here, and I'm actually not going to go through these step by step with you and show you how to do it in SPSS. And that's because your book actually does a really good job of this. And so you will, in your Lab 6, have to explain each of the assumptions given your Burfus dataset and how they either pass or don't pass. Now, I'll tell you this right now, you will be using linear regression. I'm not going to teach you the non-parametric form of linear regression, but I do want you to walk through each of these assumptions in your methods section. In fact, it might be a good idea to have a part of your methods section in your Lab 6 be specifically about testing your assumptions because there are so many of them. So again, you can see here that there are 7 different assumptions that are very important to walk through and make sure you can basically put a little check in your checkbox for these assumptions before you launch into your linear regression. I can give you a hint that this is very, very well written and easy to understand in your book. I would look on page 316. I've even given you the visual that's on page 316 of your book here to sort of understand what you have to do in order to check these assumptions. So you will have in your methods section some graphs. And so these are the graphs. This sort of tells you here about how to check each of these graphs and where they have to be set up. I'm more than happy to answer questions about testing your assumptions in office hours, but I really do want you guys to try to use your book and try to understand these yourselves without me having to walk you through them. So good luck. We will be talking about this in virtual office hours, I'm very sure, but I gave you a break on assumptions for logistic regression, but we're pulling them back in for linear regression. So again, good luck and use your book. Your book does a very good job of explaining exactly how you should test each of your 7 assumptions listed above. Okay, so now that we've checked all of our assumptions and we are confident that linear regression is the proper tool in our toolbox to use, let's go ahead into SPSS and actually do some linear regression. So what you want to do is you want to go into your album sales, go up to Analyze, all the way down to regression, same place that we were for lab number 5. And then now, instead of choosing binary logistic regression, we want to do linear regression. So go ahead and click on that. As you can see, mine, for whatever reason, is already set up, but we have our dependent variable here, and that's album sales. And so this is the dependent variable that we want to predict. So at first, all we're going to do is just use one of the independent variables, just the advertising budget, to understand whether advertising budget can predict album sales. And so the last thing that you want to do here before pressing OK is go up to statistics. You want to make sure that the confidence intervals, or the 95% confidence interval, is checked. The default in SPSS is to not give you confidence intervals, but of course we're public health practitioners, epidemiologists, and we love 95% confidence intervals. So go ahead and make sure that that box is checked, and go ahead and say continue. So say OK here, and we have a lot of things that pop out here. So what I did is I took the model summary, the ANOVA statistics, and then also the coefficients, and I put them here in your Lab 6 demo. So let's just go back here because I also have the explanations for each of these different outputs. So this first output here, or the model summary, is basically the exact same thing as we did in Lab 3 when we did a simple Pearson's correlation. There are only two variables here, and in fact, both of them happen to be continuous. So if you have two continuous variables, really all you need to do is a correlation. So honestly, because we're not using our alternative covariates or our confounders or the other independent variables of airplay time and attractiveness of the band, this is kind of too big of a biostatistics tool to use. We could have just used a Pearson's correlation. But in any case, we're learning about linear regression, so we're going to go ahead and use linear regression. So this R-squared value that's listed right here basically tells us that advertising accounts for 33.5% of the variation in album sales. So we're actually doing quite well when we just look at those two variables. And here we have ANOVA, so this should bring back a little PTSD as well. We want to look at the F statistic here and the p-value. Now, because the p-value here is less than 0.001, we can conclude that our regression model actually does a good job of predicting album sales. If it didn't do a very good job, this p-value would be higher than 0.05. So now if we go down here, we can see here that we have both our betas and then also our standard errors. We have p-values as well, and because we clicked that 95% confidence interval box, we have our 95% confidence intervals here as well. Okay, so now how to interpret linear regression. This gets a little tricky. It's much easier to understand how to interpret logistic regression because when you look at your odds ratios, all you have to understand is moving from yes to no, or high to low, or from one category in logistic regression to the other category is using that change in your dependent variable to correspond to a change in one of your independent variables. So linear regression is similar. However, we have to interpret betas. We don't have odds ratios when we're working with linear regression. So when we look at our beta values, or these are the model parameters for linear regression, and we look at their corresponding standard errors, what that's telling us is really the value of that beta, whatever that beta is for our advertising. So here we can see that our beta statistic is 0.096. That represents the gradient or the slope of the line of that regression line when we're looking at album sales. And I know this sounds a little mathy, but this will get a little bit easier here. It's associated with 1 unit change in the predictor. And if we go back to the SPSS data file of album sales, we can see here that album sales is in thousands of pounds. So when we interpret that change, that 1 unit change is in fact 1,000 pounds. So that actually makes it a little bit easier. So basically what it says is, as we increase our advertising budget by 1,000 pounds, this would result in a 96-pound increase, because it's a positive number, an increase in album sales. And of course, if we look over here, we can see that we have a statistically significant result. And we've also put our model fit over here as well. So our model fit says that we're explaining 33.5% of the variation in album sales when we account for advertising alone. But what if we want to explain a little bit more of that piece of the pie? What if we want to explain more than just 33.5%? Now we're going to get into the fact that we are going to be using linear regression as it was intended to be used, and we're going to add a couple of confounders to our model. Okay, so now what we want to do is we want to add our confounders into our model in SPSS. So let's go back here to our album sales, go up to Analyze, down to Regression, and again, we're going to choose Linear. But here, instead of just leaving our advertising as our independent variable, we want to add in number of plays on the radio, and then of course, the attractiveness of the band. So if we go ahead and say, okay, again, we get a model summary, we get some ANOVA statistics, and then here we have all of our coefficients. And instead of just having the constant and advertising, because we also included number of plays on the radio and attractiveness of the band, we have more statistics, more betas to interpret. So I went ahead and I put it here in our lab demo. So let's go here. Again, we're adding two more variables into our independent variable section in SPSS. And now what we can see is as we've added those two other variables, our model actually fits much better. So the combination of all three of these predictors, advertising, times that the song is played on the radio, and then also the attractiveness of the band actually predict almost 67% of the variation in album sales. So again, we're explaining an even larger piece of the pie as we add in those confounders. So it's a good thing that we have measured those confounders because they obviously have a big impact on the model itself. So now if we go down to our coefficients, we can see here that we have our constant, so our constant beta and standard error. We also have our advertising budget, number of plays on the radio, and attractiveness of the band. And again, because we clicked the 95% confidence interval previously, we also have this here, and we can also see that the p-values are here as well. So if we zoom down to the table, I've actually filled this in for you, and I've done this just because we are at a distance, and I want to make sure that you understand how to take those variables and then put them into your skeleton table, because you're going to have to do this on your own when it comes to your Burfus data sets. So here we have all of our betas, our standard errors, and our p-values. And how do we synthesize these results? And again, this is the tough part when it comes to linear regression, because this is the part where you really have to think, okay, how was my dependent variable set up? Because again, what we're doing is we're taking one unit change in our dependent variable and seeing how all of our independent variables change in response to that one gradient change, one unit change in our linear regression in our dependent variable. So this is how I would talk about the results in my conclusion, for example. So after adjusting for time playing on the radio, or how much time, the air time that the song got, and the attractiveness of the band. So after adjusting for all of my confounders, there was a statistically significant association between advertising, our independent variable of interest, and album sales, our dependent variable of interest. So for every 1,000 pounds spent, okay, on advertising, there was a 85-pound increase in album sales. Now that 85 pounds comes from this number right here, and you want to make sure that you have the units correct in terms of the pounds. We're getting the unit actually from our SPSS data set. Andy Field was nice enough to fill that in for us. So again, this association is statistically significant. Okay, so the p-value here is the p-value that I've taken here from advertising. And just to understand that we're really looking at how much of the pie we are explaining with these variables, it's important to also have a sentence talking about how much of the pie was explained by the model. And in this case, with the addition of time playing on the radio and attractiveness of the band, we're explaining 67% of the variation in album sales. So this really concludes all that I have to share with you for our linear regression. Again, I'm happy to answer any questions that you might have during office hours. The tough part of this lab is going to be the assumptions testing, because this is something that you're going to have to figure out on your own. And then also the interpretation of linear regression is quite difficult. So make sure that you spend some time really understanding the examples that I have here before then applying it to the BRFIS dataset. Good luck, everyone.